Bismillahirrahmanirrahim. Welcome to Bagh School Physics Department, Grade 11, Lesson number 5. Dear students, in this lesson we are going to use and understand the use of resistors in the circuits. So, later on we will also discuss thermistor and LDR, but at the present we will only discuss the resistors in the circuits. In this lesson, we will try to understand uh, to define the resistors and use of the resistors in the circuits, the color coding of the resistors, and how the resistors are made. I will give you the link of video, and then how the resistors depends upon the length of the conducting wire. Dear students, this is a simple circuit in which a bulb is being used as a resistor or load resistor. This is also called load resistor because it converts electrical energy into some useful energy like light, and also some heat energy is wasted. So, uh, why we use the resistors in the circuit? This is a useful resistor, but the some other resistors which are in the form of the, you see, a simple device, they are used to control the current. The short answer is resistors are used to reduce current through the resistor path, cause voltage drop in the resistor path, or to dissipate electrical power through heat. So they are can be the resistors can be called as current controlling device. Here we can see the resistors. These are the resistors. As I say, it's a current controlling device. So if the LED is connected directly to the battery, it may burst. That is why a suitable resistor is connected in the series with the LED, so that a controlled current can pass through the LED and LED remains working. So this is the function of the resistor. So the main function of the resistor in a circuit is to control the flow of current to other components. Like we have taken LED for example. So if too much current flows through the LED, it is destroyed. So a resistor is used to limit the amount of current passing through the LED. So actually the resistors are having a particular value. So the value of the resistor is understood from the color coding on the resistors. So how to read a resistor value? This is on the left hand side. You can see the it's a color coding. For example, the 0 is shown with the black color, and 1 is shown with the brown color. So if the color is red, then the value will be taken as 2. If the value the color is orange, then the value will be taken as 3. 4 for yellow, 5 for green, 6 for blue, 7 for violet, 8 for gray, and 9 for white. And if the color on the right hand side is brown, it means the resistance is of 1% tolerance value. Then if the right side most color is red, then resistance tolerance value is 2. 5% for gold, and silver have 10%. Okay, now in this example you can see that the first color is brown. So the value of the brown is 1. So we will write 1. Black, then second color is black. So it's a second digit. First color is for first digit and second color is for second digit. So for brown we will write first digit 1, then for black the second digit 0, and the third color, which is actually red, it will give you the number of zeros. So it is red, so there are two zeros, and hence the value becomes 1000. So this is 1000 ohm. Now the rightmost color is you see gold, so the tolerance will be 5%. So hence we can write down that the value of the resistance is 1000 ohm with the tolerance value of 5%, which in other words you can say the value of the resistance may vary from 950 to 1050 ohm. We take uh, for example, you can see here this resistor color code chart. The first is red, so red means the value will be 2, the first digit will be 2. Second is also red, so 2 and 2, the it's mean 22. Third is brown, so brown has 3, sorry, brown has you see 1, so it means 220, 220. So the resistance of this resistor will be 220 ohm with the gold 5% tolerance value. Hence we will say that red, brown, gold will have 220 ohm resistance with the 5% tolerance value. And similarly you can have another examples like brown, green, brown, gold. So brown is 1, green is 5, so 1 5, and then brown is 1 means 10, so this becomes 150 ohm with the gold 5% tolerance value, and so on and so forth. So this is how we can read the value of the resistors from the coloring code of the. So when we talk about the how resistors are made, I'm giving you the video link down. It's a very beautiful video and very you see informative video. This maybe it's not in our course, rather we can say that how the resistors are made is beyond our course. So I just want to give you the opportunity to watch this video so that you can understand how the resistors are made. Okay. Now the resistance of the conducting wire, as you know that there is a copper wire or any conducting wire, it might be thick or it might be thin, or it's very long or it's very small. So the resistance of a conducting wire depends on thickness, the cross sectional area of the wire, and the length and temperature. So these are the three things on which the uh, resistance of the conducting wire depends. Normally we say that the temperature of the environment remains same, so we just consider temperature as constant. So the length of the wire, if it is greater, the resistance will be large, and if it is the cross sectional area is greater, then the resistance will be small. So the resistance is directly proportional to the length, and it is inversely proportional to the cross sectional area. So when we formulate the equation, then equation becomes R is equal to, R is the resistance, is equal to resistivity into length over area. So this is the formula for the resistance of a wire whose length is capital L and whose cross sectional area is capital A, and the resistivity is rho, which is constant value for a particular medium, and resistance is symbol is like this one. The rheostat, it's a variable resistor, and again it depends upon the length of the wire. As you can see, the whirling wire on the green cylinder, this one, starting from A, then you see it's a kind of loop on the green cylinder, and ending at C. So from A to C, it's a length of the wire, the coil of wire. So there is a moving pointer on the blue cylinder. Blue cylinder is a moving pointer in orange color. So when the orange color pointer moves to the right, it means the length of the wire is increasing, because we take the length of the wire for the resistance from point A to the contact, orange contact. So if it moves towards right, the orange the length of the wire will be increasing, and the resistance will be increasing, because the cross sectional area of the length wire and the resistivity remains same. So only it depends upon the length of the wire. So as the orange pointer moves on the right, the length of the wire from point A increases, and hence the resistance increases. And if it moves on the left side, then the length of the wire decreases, and so the resistance of the wire decreases. This is called a rheostat. It's a variable resistor. A rheostat is a variable resistor which is used to control current. They are able to vary the resistance in a circuit without interruption. The construction is very similar to the construction of a potentiometer. We will discuss later on the potentiometer as well. All right. So thank you very much. In this video, we have tried to understand the resistor and resistor in the circuits. In the next lesson, lesson number 6, we will try to understand the thermistor and LDR in the circuits.